Hi students, I am Prashant B. Chandran, Assistant Professor Automobile Engineering Department SN80 Adoor. Okay, today I am going to teach you another problem on LMTD method. Okay, let us start the problem. Saturated steam at 120 degrees centigrade condenses on the outer tube surface of a single pass heat exchanger. Okay. Determine the surface area to heat 1000 kilogram per hour of water from 20 degrees centigrade to 90 degrees centigrade. Find the mass of the condensate. Take heat transfer coefficient U is equal to 1800 watt per meter square degree centigrade, and HFG is equal to 2200 kilojoule per kilogram. Okay, this is the question. Okay, that is once again dictating the question. It is given that steam is saturated and the temperature of steam is given as 120 degrees centigrade. Condenses on the out means it is a condenser. Okay, on the outer tube surface of a single pass heat exchanger. Okay, steam condenses means we have to consider the temperature as constant. This is a single pass heat exchanger. Determine, we have to find out the surface area and the mass flow rate of the fluid is given, and the cold fluid, if you consider its inlet and outlet temperatures are given, we have to find out the mass of the condensate. Overall heat transfer coefficient U and HFC are given. These are the given data. That is, first of all, hot fluid here. Saturated steam is the hot fluid. So it is a condenser. Therefore, T1 is equal to T2 is equal to 120 degree. Okay, but you have to note that point. It is in a condenser. The inlet temperature is equal to outlet temperature. Then cold fluid is water. Its mass flow rate is given. Have to change it into kilogram per second. Then inlet and outlet temperature of water are given. Then oral heat transfer coefficient U is given. Okay, to find, we have to find out two things. First one is surface area A. Second one, mass of condensate, that is steam. Steam is the condensate here, that is m dot s. Okay. Solution. First we have to find out the surface area. Okay. For finding surface area, you have to first find out the LMTD. That is logarithmic mean temperature difference. Okay. For finding the LMTD, we have to draw the temperature distribution diagram. This is the first step. As you know, you have already seen that in my previous videos. I am drawing the temperature distribution diagram for a heat exchanger. This line represents, that is hot fluid. Here the hot fluid is steam, condensate steam. That is steam. Condenses means the temperature remains constant. Therefore, it is a horizontal straight line. Temperature does not increase or decrease from inlet to outlet. T1 is equal to T2. Okay. Then I am drawing the curve for cold fluid. Cold fluid is getting some heat, that is its temperature is increased from 20 degree to 90 degree. T1 is equal to 20 degree and outlet temperature T2 is equal to 90 degree. Left side we know that the left side heat transfer, the left side temperature difference gives theta 1 and the right side temperature difference gives theta 2. Okay. This is a note for you. That is, in a condenser, T1 is equal to T2. That is, inlet and outlet temperatures are same. Temperature does not change. Okay, in a condenser. And you have to Keep it in your mind always. If in the problem the word condenser or condenses comes, it is a condenser. Okay. Then you know that the left side temperature difference gives theta 1 and right side temperature difference gives theta 2. LMTD is equal to theta 1 minus theta 2 divided by ln of theta 1 by theta 2. Here theta 1, it is a left side temperature difference, capital T1 minus small t1, that is 120 minus 20 is equal to 20, so 100 degrees centigrade. Theta 2 is the right side temperature difference, that is capital T2 minus small t2, that is 120 minus 90, which is equal to 30 degrees centigrade. The next step is substituting the values, these values in equation of LMTD. Once again I am writing the equation. LMTD is equal to theta 1 minus theta 2 divided by ln of theta 1 by theta 2. We have already found out the values and I am substituting that values for theta 1 and theta 2. This theta 1 is 100 degree, 100 minus 30 divided by ln of 100 by 30. We get the value for LMTD as 58.14 degrees centigrade. This is the value for LMTD. Okay. The next step is to find out the heat transfer Q. We know that heat transfer Q is equal to m dot C CPC into T2 minus T1. Okay. We'll consider in the cold fluid m dot C CPC into T2 minus T1. Okay. It is m dot C, it is given as 1000 kilogram per second. And for water, CPC value is 4187 joule per kilogram Kelvin or 4.187 kilojoule per kilogram Kelvin. Yet substituting the values as 4187 joule per kilogram Kelvin into T2 minus T1. We get the value for Q heat transfer Q as 81394.4 watts. Okay. CPC that is for water, Suzuki it is 4.187 kilojoule per kilogram Kelvin or 4187 joule per kilogram Kelvin. Okay. There is another equation also for heat transfer Q. It is Q is equal to UA LMTD. Therefore, A is equal to Q divided by U into LMTD. Substituting the values, we get Q is 81394.4 divided by U is 1800. The LMTD is 58.14. ID for LMTD is 58.14. For area is equal to, we get 0.78 meter square. This value for area. Okay. Our second part of the question is to find out mass of the condensate, that is m dot s. It is the rate of condensation is given by another equation, that is Q is equal to m dot s into HFG. Okay. You have already studied this equation in thermal engineering. Okay. Q is equal to m dot s into HFG. HFG is given. Q we have already found out Q. Therefore, m dot s is equal to Q divided by HFG. That is equal to Q value is 81394.81394 81394.4 divided by HFG is given as 2200 kilojoule per kilogram. So because I have to convert that into joule per kilogram. Okay, that is I get the value for m dot s as 0.0307 kilogram per second. That is 0.0307 into 3600 kilogram per hour. That is m dot s equal to 133.2 kilogram per hour. This is the answer. Okay. Thank you for watching this video.